Hello pre-calculus students, and welcome to the lesson on real zeros of higher order polynomials. And this is somewhat of an overview here. So if we have an example like this, f of x equals 3x to the third plus 5x squared plus 8x plus 7, okay, we can solve for the zeros graphically. Okay. We can think about these things in terms of end behavior. We can find it. So we can do this graphically. We can find end behavior. And one of the issues that we talked about last time in the previous section is multiplicities and factor form. So one of the main ideas for today is how do we get this to convert into factored form. Okay. And this is a very long process. It's actually a very difficult concept. So, so in this lesson here, what we're really going to do is we're going to be given one factor, and then we'll be able to find other factors. Okay. And then later on, we'll be able to find the given one. So later we'll be able to find this factor too. Okay? But for today, we're going to be given one factor, and we're going to learn how to get all the other factors from there. Okay? So that's the big idea for today. You have a higher order polynomial, with something with x to the third. We want to get it into a factored form, but it's really hard. So for now, we're going to be given one factor, and then we're going to have to use that one factor to find all the other factors. Later on, we won't need to be given anything anymore. We'll find all of our solutions on our own from the very beginning. So let's get going here with an example. And it says here, find or divide this expression by this expression. And I'm going to call this f of x, and I'm going to call this g of x. Okay? So we're looking for f of x divided by g of x. And if this has remainder, so if f of x has a remainder, f of x divided by g of x has a remainder, okay, then then g of x is not a factor. So first we want to decide, is this a factor of this polynomial? If it's not, if it has a remainder, then it's not. Okay, so and there isn't really a great way to do this, but we're going to use a long division from our days of elementary school. So I'm going to write this here. I'm going to divide it, writing this division bar right here, by 3x plus 2. Okay. And so the first thing we're going to do is looking at this leading term here and seeing how many times does 3x go into 3x to the third. So 3x to the third over 3x equals x squared. So x squared goes here. Then when we multiply, we're going to multiply x squared times 3x, gives you 3x to the third. And you have to multiply x squared times 2. So this is going to give you 2x squared. Okay. And same as the rules of long division, you have to subtract, but you got to be careful here. You have to subtract the quantity. These are gone. Now it gives us 3x squared. And then we just repeat the process again. How many times does 3x go into 3x squared? Should give you x. Multiply. This gives us 3x squared plus 2x. Oh, and I forgot to bring down this 8 here. Excuse me for that. I'm supposed to bring down the 8. Now we subtract again. And this is going to give us, always going to go away. This is going to give us 6x. Divide one more time. 3x goes into 6x twice. Multiply it out, you get 6x plus 4. Bring down the 7 here. Subtract, and this gives me 3. So this is my remainder. So this is remainder 3. Okay, so one thing that we can conclude, because there is a remainder, so because there is a remainder, 3x plus 2 is not a factor of f of x. Okay, so we want to determine, first of all, we're given this here as a starting point. Is it a factor? If it's not a factor, we can't really go much further. And you can see here, it's a bit of a pain to do this long division. Okay, so you can kind of see ahead here that we're going to get to what's called the remainder theorem. And the remainder theorem is sort of a special case that will help us to determine if it's a remainder faster. Okay, so I'm going to end this video here, and we're going to pick up in the next video starting with the remainder theorem.